Hey, good morning. It's 11 a.m. on April 12th, 2020, and we're gonna do a little programming this morning. I think it's gonna just be like optimizing and stuff, so it might not be very, how should I say, won't be very exciting in the PCG realm, but we'll see. Maybe we'll get there. Here we go. So, alright, one of my main problems, well, while we're here, I was doing some research in PCG, and this is what I've got so far, if you want to take a quick look. So if I have a quad, put some light on it, I'm gonna generate 1D Perlin noise on here, and a 2D. Maybe we'll look at this a little bit first before I get started on the optimization. So let's see. I'm gonna add a light. I'm gonna move this light out the way. Which one's the move? That one's the move. Alright, so here's a quad. I'm gonna go ahead and put this like Perlin test. And so I'll just show the code right quick too. So this is our implementation of Perlin noise. So we're doing just a 1D one. So we pass in a float. This float could just be T. Let me see. I'm gonna name you Faded T. You'll be T. Sure. So we're passing in a time variable, right? And so what we're doing first is just getting the int part of time. And sorry, I got distracted. So we got the int part of time, and then we're getting the float part, or basically everything after the decimal. I called it the float part, but maybe it's like the decimal part. But anyway, and then we're running this like fade function, and this fade function, well, I still have this Excel up and didn't close it yet. Like what I did here is I made a graph, and this first line is just 0 to 1 at increments of 0.05. And then this is the equation in Ken Perlin's paper, which I guess if I click on here, you can see it's 6 times t up 5, 15 times t up 4, and 10 times t up 3. So that's the equation, and that equation leads to this kind of sigmoid-ish, but not really, kind of like smooth line. And so that's our faded T. And then we get a random number. First random number is using, we have this, well, I guess before we do any of this, we would generate this like list of random ints, and we're using the int part to get the first like random int, and then the next random int, and then we're gonna like fade nicely between those two. And here we're just simply lerping between the 2 points, but we're lerping using the faded T. So like that time goes like that, right? It doesn't go straight linear. So we kind of modify time using the fade function. And then there we go. then we're just mapping. Uh, mm, yeah, I uh, I was messing with this. So I oh I see. I'm not using any kind of gradient vectors. So this is straight up like using the random numbers, which is going to give us some interesting results, I think. But so it's not quite the Perlin noise that we know and love. It's kind of a modified version of it. So let's play that right quick. Oh, I didn't actually set a width and height up for the texture, so let's just make this 256 by 256. Yeah, so that's our texture, and then like I can kind of just keep scrolling it, and you can see it's just this like random thing. And then if we, here I'll put it back at 0, I could change the seed. So, you know, every time I change the seed, it changes that list of numbers. And if I made the scale kind of bigger, oops, that's the seed. I could keep moving this. So it's an interesting kind of noise. It's not the Perlin noise that like is pretty uniform and you add octaves. Like this kinda just does its own thing. So I guess I could call this like a modified Perlin. Alright, so that's that. I should bring this back to the original Perlin, and I actually have like a OneNote. I actually might make like a whole video. I know there's a bunch of Perlin noise explanations, but I want to do the 1D1 like better. I feel like I could do it better, maybe, than stuff I've seen on YouTube. So here we go. So like this is kind of the more uniform version where like at first we have random values, but then we start using well, I'm not going to explain it all here, but anyway, we have all the instead of using random values, we just have a bit basically that says, oh, which way is the vector, your gradient vector pointing. So in 1D space, we have like we can go up or we can go down, and that's all we have. And then we kind of make these gradients. So like this is time t. So like remember we're just looking at the decimal part. This is the decimal part going up between each integer. So if this is like 1, 2, 3, 4, 5, this is like 0.1, 0.2, 0.3, 0.4, 0.5 up to 1. This is 0.1, 0.2, 0.3, 0.45. So it's basically multiplying this vector times t. And so you're getting these kind of lines shooting out. And then if you got the inverse of that line, you'd get these lines going down, right? So if you added those together, you'd get this kind of sawtooth thing. And then if you applied like that fade function I showed earlier, this guy, to this sawtooth thing, you'd get this nice like cosine wave thing, and boom, that's like Perlin noise. And then if you wanted to change the amplitude or change the detail of it, you'd add these things called octaves, or basically you could sample time even faster, and then you get this like really more noisy thing going on. And so that's 1D Perlin noise with the 2 vectors. And then 2D will have basically 4 vectors pointing in 4 different ways. So, and what people notice is that they have better chance shooting in the diagonals, right? So that's Perlin noise. So I got my head around it. It took me a couple days, but I got it. And yeah, I'm excited about that. So that's what we're implementing here. What I probably have to do is in my test, instead of using the random ints, we should go ahead and use the gradient vectors, which is basically that. So I think I can quickly do that, right? So we just say gradient vector A equals gradient vector random A. Is that what you need? Oh, and I guess you need my actual. So this is yeah, maybe just for, I know I'm multiplying it by x here, but really I know I'm adding an extra step, but this is more helpful for me. So I'm just gonna get the gradient vector from a random number, and this is the gradient t. Is that the gradient t? Yeah, okay. I think so. So we're just gonna get the faded t here, and then the inverse gradient t equals this isn't feeling right to me for some reason. So what are we doing there? I'm getting these vectors, right? I'm getting that vector. I'm multiplying it by t. So that's the gradient t, and that's the inverse gradient t. So that's really that one point here. Oh, I guess. Stand by. I'm thinking. Is it that I just want the same gradient? Do I just want the negative gradient t? So I'm getting the negative gradient t, and then I'm gonna do one. Oh, I don't need to do that. I could just do this 1 minus this. Is that what I want? Or minus 1, and that way I get kind of this negative thing. Yeah, that feels more correct to me. Oh, but this is giving me issues because what do you need to be? Oh, I see. I don't need to pass this x anymore. I'm going to say some random number. And so if the random number is divisible by 2, I said give it a 1 or a negative 1. Okay. So that is giving me that. Okay. And then the inverse is just the negative part of that, right? And the value, I just want to say, is the sum. Right? Alright, let's assume I'm not fading t. So we'll just say faded t is actually equal to t. So it's going to be that sawtooth wave is what I'm hoping to get at this point. And so the value is going to be grad t plus inverse grad t. And that's going to be a value between 0, I want to say 0.5. I'll just do it 1 for now, but it's 0.5 because you can see my inverse is just going to be, the maximum it's going to be is halfway up because of the X shape. So Yeah, I don't even think I need to map it. Let's just return the value. Okay, let's see if we get a sawtooth wave. Alright, let's... Got an out of bounds array thing. We're at here. Okay. So that just means the Y is way off. I could be getting a negative. Okay, yeah. Got it. I know. If I go here, go to my Perlin noise, I could be getting a negative. So let's just go ahead and map -1. Ah, come on. All right, let's debug. Uh-huh. Mm-hmm. Hate all these like Unity exceptions. Here we go. What's my Y? 258. So that means my pixel height is 256, which means this is being more than 1. 258. That means it's too high. It's more than 1. Okay. So Perlin noise is coming up with too big of a value here. Okay. Here we go. So, we got the end part, the faded part. Okay, so we're using T. T is just gonna be... Oh, I need to use the float part. That was my problem. I was using the whole T, so after 1, it was just gonna be too big. So that's what I needed to do. Interesting. I don't understand the shape. Alright, so we are using the float part now. We're getting this int part, and we're multiplying the float part times our gradient vector, which should just be -1 or 1, right? And our inverse gradient t, we're just multiplying this gradient t. Oh, this should be not times, but minus or plus. Plus this guy. Alright, well, that. Oh, no. We basically get the gradient vector times this. Yeah. And if we plus this and then the minus that, that should be between -1 and 1. Okay. Let's do like scale 4. Ah, man. Alright. Where are we screwing up here? I'm going to stop here if value is greater than 1 or value is less than -1. Conditional break. And let's play that. Can I like ignore this? Mute and resume. Mute and resume. Mute and resume. Mute and resume. Alright, no problem there. But it's running really slow. Why is it running so slow? Put the profiler up, see if it tells me anything. Oof. I'm gonna pause. Alright, what's causing this to run so slow? Alright, if I look at the hierarchy, it's definitely the update loop, okay. But what's causing it to go so slow? Oh my gosh, so many classes open. Alright, so let's close others. So you're just basically saying this guy's doing it, and I guess it's this guy, and maybe you're not. Okay. Let's just do like 100 by 100. Might need to close this. This is just being too crazy. This is an argument exception. Yeah. Like, I want to stop at these, but alright, let's just not stop at these. Alright, you know what? Do we have like exception settings? Let me not do any exception. Let's just do the one we know is gonna be the error. Well, okay, let's get the error first. Alright, let's continue on. Let me, you know what, let's just, I'm having a lot of performance issues. I'm going to just shut it down for a sec. Yeah. I think it has something to do with the communication between Rider and Unity. It was like, it was getting out of hand. Ah, I gotta create the scene again. I need to save that scene. So here we go. Quad, light. Let's move it. And let's give you the Perlin noise test thingy. I like 256. And then I'm just gonna make this 5. Out of range, index out of range exception. Okay, that's what we need to do. Just stop there at index out of range exception. And so we could do this debugger thing. We can do index. We could do this guy. If you could just help me find index out of range, that would be awesome. It should be system. Maybe just system. Index out of range. Okay, so now, hopefully, you'd stop only there. Yeah, okay, it looks like it's stopping there. My value is negative 1.03. Oh, I know. I didn't put the parentheses around there. Okay. And that was the issue. This operation takes place later, and that causes the wrong uh, relationship there. Alright. There we go. That's what I was looking for. Alright, so back to 1. Maybe even like 0.8. Just where it looks kind of nicer. Alright, I guess that's fine. Then we can kind of go through here. We got this kind of sawtooth thingy going. Sometimes it goes down, sometimes it goes up, and that's fine. Oh, but you see, it starts over again. Right, so that's the problem of this. It needs to somehow go to 0? Thinking about it, thinking about it. Alright, so the value, I see. In my drawing, the value needs to like peak at the middle, which I don't think it's like adding the or subtracting it correctly. So let's figure out what I'm doing wrong here. Okay, so this should be going up as the decimal part goes up, and this should be coming down. So if you're like 0.1 and then you're negative 0.9, right? When I add you two together, you should be like 0.8, right? No, you're just... Alright, let's just take the simple one. 0, you'll be at 0, you'll be at 1. Let's go to the more complicated one, 0.5. So 0.5, you should be at... I'm thinking. At 0.5, you will be at 0.5, you'll be at negative 0.5. I take you minus you, you'll be at 0. Right? And then at 1, you'd be at 1, you'd be at 0. I'm having issues. Can't think of this straight. I realize I'm just getting the negative, but it's not just the negative. It's like the negative, but shifted up one. So, alright, so if I just took the gradient, and then I added the inverse, is this just a plus? So if you're at -1, and let's just say you were a -1, you'd be at 0. I'm doing this wrong, and my mind is not getting it. Oh, this should be so simple. Sorry, it's just Sunday morning, I guess. Alright. This case, super simple. The reverse case is just, it's getting me. I mean, I know how to get this line, and I'm just trying to get this part, right? So if I add these or subtract these, I will definitely get it's almost like a math min, or the smaller, right? Is that the function that I'm using here? Yeah, my mind is just thinking about this. I should totally, if I'm gonna do this formula, doesn't seem to be the sum of I mean, this is all right. Let's look at a different implementation, just because I'm stuck. Oh, actually, I have it right. It should be right in here. Perlin noise 1D. Okay. The fade function I think is the same. This is the 2-dimensional. Let's do the 1-dimensional. Alright, so you are getting this gradient times the x, right? And you are getting the next gradient, and you're getting it from, and you're getting the inverse of it. So that negative number. I'm gonna do it. I can't see it. I can't see it right now. Let's do it though. Let's do it. So you're getting the next gradient, and you're doing it times the next the previous, yeah, the inverse. And then what are you doing? You're just lerping, right? Yeah. With T. Right. So value is the min part, which is grad T plus T times inverse grad T minus grad T. Is that going to give us what we want? Just for the sake of it, trying to add it twice or something, or negative on a negative. Oh yeah, I see. Thinking about it, thinking about it. Fine, let's just go back to what we had. So we have time, we have a gradient. We're gonna go ahead and just apply the faded t to this, and the faded t minus 1 to this, and let's go ahead and add a lerp if we don't have a lerp. And this is going to just be float A, float B, float T. And I'm just going to steal it from this guy. Yeah, that's what I think I... Where basically we get A plus T times B minus A. A plus T, B minus A, yeah. So we totally did that, but okay. Lerp, grad T, grad inverse T, T. And we'll see what that does. Nope. I'm doing something else wrong. Seems to be right. don't know. I don't know. Alright, let's go ahead and debug and figure out what's going on. Okay, so our value is that. Our float part is fine. Our randoms are definitely okay. Got a really small number there. Got another small number there. Our T, what's our T? Oh, I'm doing the wrong T. Fade it. T. Okay. Okay. +5. So it seems to be moving and randomly doing something. If I do, you see it's not giving me that though. Yeah, I think I need more of a, like, this thing going on. And if I do like a unity 1D Perla noise, it's even, the amplitude's more random. Okay, so something's up with mine. I don't think it's the seed, because there's a lot of like empty area. So I feel like it's something to do with my gradients or something. Could totally just compare. I don't know. Alright, so you're getting the gradient. Your gradient is just x or negative x, right? I get that. And yeah, okay. I'm mapping from 0 to 1. The online one's from -1 to 1. Let me just do that. I'm like, since I'm kind of taking most of this, -1 to 1, -1 to 1, everything else is cool. Yeah, okay. And I'm getting the int part right, no problem. I'm getting the float part, cool. My fade hasn't really changed. Getting 2 random ints. Alright. Getting a gradient vector using random A and that faded t. Then getting another gradient vector with faded t minus 1. And we're going from there to there using faded t. And now I'm just going from -1 to 1 to 0 to 1. And that is that. And if I put scale to 6, but then if I put it as online, you're in the middle. I put it up here, you're like squished up here. Why? I don't even have the map function, right? Oh yeah, I do. Just return the value. Okay. That was my mistake. That was an honest mistake. Here we go. So sometimes it goes up, sometimes it goes down. And if I just say you're the float part, what happens? Okay. Stealing this. I don't think this makes the difference. I don't think so at all. No difference. Okay. Okay, this is what I'm going to do. You got the in part. I'm going to go ahead and erase the int part. And if we really want to, we can fade it. But not sure that I will yet. We're getting the perm A, right? And perm A plus 1. Perm X and perm X plus 1, right? Which is just two different random numbers. And then we're getting two gradient vectors. Okay, I'm starting to see something. Okay. I'm just gonna try something. Interesting. Okay. Um, Starting to see something. I don't know if you're seeing it with me, but here it is. Alright, so we have this. Um, this is us lerping between what? Just want to make sure I'm saying this right. Let's put this at a scale of 1. Alright, so this is a scale of 1. We're looking at possibly two increments. Let's also see if I can add like a red pixel at the beginning of each. I want to say if it's the 2D. Alright, this is the X, right? If the X is how do I say this? Alright, so we're going to do this in white unless otherwise I'm going to make it red. And that's if this time scale plus offset minus the int part, which is int x. How am I getting the int part? Oh, math.floor, right. Math f.floor x equals 0. 2 equals. And that's okay with the rounding. I'm okay with that. Let's try that. Not really sure that I see anything. Alright, let's actually do what they recommend. Less than 0.01. Maybe we can kind of see the couple red pixels. Or no red pixels. No red pixels. Okay. Let's just say if you're less than 1. Oh. Maybe I need an absolute value. Or, oh, I'm doing all sorts of stuff here, I just realized. I noticed the errors of my ways. Here we go. Still compiling. Coming up. Nothing. What am I doing wrong here? I guess what I'm really trying to say is how do I know when I'm yeah, I don't know. Maybe if I just do the first half red, second half did I save it? Maybe I'll make this a 5. Okay, should be compiling. Should I just replay it? So we're getting this float number, I hope. It might not be a float number. Yeah, this is gonna be not a float. Till I do that, maybe. Come on, what am I doing? What if I say just not equals to this? This should always be 0.5 then, right? I mean, it should always be red now. I guess not. What is the problem? I get it. If this is true, color should be red. And I'm in the wrong function. And it all makes sense now. Okay. Color dot white, sure. Let's go to mine. Alright, let's do what I was trying to do here. If something, do that, else something else. Make it red. Or actually this could be the white and this could be the red. Okay, if we'll say var transformed x equals this, and then we can just grab this, even name it t. I'm cool with naming it t. And then we're gonna say if t minus math f dot floor t equals 0, make it red. That'll just be 1 pixel. Ah, yeah, cool. And if we did it like less than 0.1, that should be maybe a few pixels. Or no pixels at all. How about 0.5? Oh, I made it negative. There we go. There we go. So that's all of it. How about 0.1? 10% of it. Okay. That should be like your first 3 pixels. Okay, cool. So, now we can see every like time point, and it should be like here, 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 here. Okay, that's one thing. Um, so all this is telling me is if this is pointing up and this is pointing down and this is pointing up, you get this kind of, is that what's happening? I want to keep like adding things to this just so I can understand what's going on visually. And maybe I should. Well, we do have T, so maybe I can do something like that. Like if it's pointing up, make it yellow. If it's pointing down, make it blue. Yeah, let's do that. Or red and blue. Red being down and blue being up. So okay, if gradient vector, let's get the floor portion of T. So that's the floor portion of T. And now we need T, I guess. Or math floor. T minus math floor. Yeah. So we have that. Oh, if it's greater than 0, you're a number, right? You're a float, right? So we have this gradient. What are you complaining about? Oh, you should be an int. I think we have a function for that. And we'll just do another else if the gradient is less than 0. We'll make it blue. Alright, I just realized maybe I still want the first 3 pixels to be red, so we'll make that at the top here. So if the first 3 pixels, that would be if T minus math f dot floor T is less than 0.1 f, then make that red. Okay. I think that looks right. Let's see if that actually compiles. Oh yeah, there we go. Oof, I don't like how it seems to just be blue, green, blue, green, blue, green. That's not what I subscribe to. Let's figure out what's going on here. Let's keep offsetting this by 5, by 2. So we got blue, green, blue, green, blue, green, blue, green, blue, green. I don't see like a blue, blue. It's like blue, green, blue, green, blue, green, blue, green. So what's that mean? Oh, I'm doing the wrong value. We have t, um, but that's just based off of x. That's based off of time, so that will always go back and forth. Because this should go 0, 1, 2, 3, 4, 5. So you expect that to do the blue, green, blue, green. I need to get the random part of this. So wherever I'm doing that, this guy, I'm just gonna grab it. So let's just get the random list of ints right in there. Random list of ints. Maybe this will be different, I'm hoping. Ah, yeah, that makes me feel better. Let's check it out. Alright, so if we have like green, so green means it's going up. So up, 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 up. So it has like an up and a down. It does that. Okay. Let's keep it going. So really the only way you see these jumps are if there's a change, right? So if you go from green to blue, that's when you see this. Oh, that's when you see this. And then now it's a blue to green, that's when you see this. So green, but you see blue, blue, there's no change there. But then the next blue to green, you see that. I see, I see. I'm starting to understand that. And then it's only into changes. Okay. And that works because you're getting this gradient times time times this gradient times your inverse. So if you have x, yeah, if you have t going here, t is this, and negative t is this. You basically just have this going like that. Okay. Okay. So, and then if you subtract that minus that, which is what this was, you'd get a flat line, right? And then only if you're subtracting this minus this, which is actually the a big version of that. Okay. Man, yeah, that's complicated. Oh my gosh, Illinois is no joke. But I think I got it. Alright. And then if you add a little squiggle in between, which we'll do right now. So how do I get my Illinois? So now if I run that fade function on it, go. Then you can like zoom into this. And we can, oops, not the Y offset. So that's Perlin noise a bit, but it's very uniform, right? It's just like up or down. And if you have a change, it goes even higher, right? And if you have a change, it goes even lower. But if there's no change, you just get this. There you go. And so that is Perlin noise. Okay, cool. Now this is just one octave, right? So we are, but the way to get more details, you can squish the time and get more details in here if you wanted to. And we could, but I'm not gonna do that right now. Not sure. Okay, I'm gonna rename this part a little bit. Let's call this fade it T. I don't know if I should call it the fade function. I'm gonna find that paper and see what he calls it. Oops. No, don't open up source tree. Ken Perlin 2008 paper. Yeah. Is it noise? Improving noise. A 2002 paper. Sorry, I'm looking at the wrong screen. So this is the paper. This is replaced by this. I'm reading this, sorry. We'll call it the cubic interpolant function. Well, let's call it the interpolant function. Cubic interpolant function. Just to keep it consistent with the paper, although it's really crazy here. Cubic interpolant function. Cubic interpolant of T. Interpolant T. Alright. I know, silly, but I just wanted to make sure we're just saying the same thing. Typo, interpolant. Yeah, that's fine. So, yeah, we got 1D Perlin noise. Yay. What's still bugging me is I don't understand it. Well, like what? I'll tell you what I don't understand. Let's just say I don't get the interpolant of T, right? All right. what is happening here? Why is it like this curve? I understand I'm getting this kind of line that goes like this, and I'm getting this line that goes, I guess, like this. So I have this line that goes like this line that goes like this, but maybe it's going like this, which would be better, I guess. Like, right, I get this. I get this line coming out. You're a negative gradient, so as time goes on, you're going to be a straight line like that. You are going to be a straight line. You are going to be random b and t minus 1. So you're going to be up. You're going to be like this, I think. Is that right? Alright, so at 0, you're at 0. You're at 1 here, I guess. And you're going to be negative 1, so you're actually here. And time is here. Okay, so that lerp function is what's causing that. So you're here, and you're just going to simply go up like this, I believe. Maybe. Yeah, you're going to go here. So that's your line. You're like this. You're like this. I am, as time goes on, I am, I see. I am going towards you, and then after the 0.5, I'm actually getting closer. Like, this line is still going like this, but now I'm getting closer to that, and that's why I get this curve. It's this lerp function that's doing that. Yes, okay. That makes sense. Okay. So that's what's causing those little hump things. Okay, okay. Now that I get that, this whole fading thing is a whole different thing too. So this guy is using this function. So instead of that straight linear thing, you kind of go down and up, but imagine it rotated, I guess. So instead of going straight, you're going down and up like that. Okay, that makes sense too. Okay, I think I'm getting it. So, should we add an octave just to see what happens? So this is what I'm going to do. I'm going to add 1 octave. Just add it to the y. All we're going to do here is we have the function already. Let's go to my, this my 1D, go to my 1D1. So that's the unity Perlin noise. So here's my Perlin noise 1D. So we have this y. What if I said y plus equals? Imagine if we took this Alright, let's also change t. Alright, so let's say we doubled the scale, I guess. And halved the amplitude. Something like that. I'll just do that. Times 2. I'm going to just divide by 2 here. So I basically times the scale and divided the pixel height. So now we're only getting half. Okay. Or I guess I could put the divided by 2 even outside of this. Okay. So I times that by 2. Should the offset be timesed? I don't think so. Okay. Let's see. Let's see if I screwed that up royally. Okay. Yeah, I suspect something like that could happen. Let's just say if y is less than 0 or y greater than pix height minus 1, stop there. Which I'm sure it is. I just want to see how bad. So y is 256, I see. We'll just clamp it. I think that'll be fine. If y is greater than or equal to 256, y equals 255. How about that? I feel like I'm doing some weirdness too. Maybe we don't map it right away. So we just get Perlin noise like this. We'll just make you V. And then we change the T. Then we just say V plus equals this. Maybe divided by 2. And then we just say y equals map V minus 1, 1 to 0 pixel height minus 1. And that'll just be our yeah, I lost it. We'll make that an int and call it a day. Maybe I'll just make this var t2. Let's see. Let's see how bad that looks. Alright, I'm getting some variation there. And then if I change the octave, the seed. Okay, that's looking pretty good. If I add like 2 more octaves, that might even look better. Which, let's do it. Let me see if I do the X offset, does it move nicely? Oh no. Okay, that does not move very nice. Okay, okay. So maybe I times this whole thing by 2. Do I just say T times 2? Yeah, that looks good. Let's make this back to 1. Alright, so that's fine, but when I start moving it... Oh, there we go. Yeah, you just multiply the whole thing, and that moves nicely. Okay. So let's add 1 more octave. T3 equals T2 times 2, and then we'll just say V plus equals Perlin noise T3 divided by 4. I think that'll be good. Alright, so we keep adding these octaves, and hopefully this adds this nice, like, difference to this. And, oh my god, maybe I should just make sure I start off with 1. Alright, so that's looking nice. Change the seeds here. I can kind of hopefully just keep playing with that. Yeah, that looks fun. And then if I do the X and the offset, yeah, the X offset changes nicely. And then I know you can't really see it because of the pixel density, but the more I scale it, the more jagged it starts to look. But it also has like these nice fine details. 1 more time. 1 more octave, and then I'll be done playing with this. Hello. I don't know how to say your name. Sorry. But yeah, I'm just messing around with some Perlin noise. And there we go. That looks really nice. And I broke it somehow. It's not giving me an error though. Something to do with the UI, I'm guessing. We can add maybe like 0.5. And that way you can just kind of see. Oh, and I guess it might help if I turn down the scale a little bit. Alright, and that's it moving in space. I keep breaking it. Why is it breaking? And it's not like giving me an error. Is it you? Are you causing the problem? I don't know. Okay, so safe to say I've got a couple octaves working and it looks pretty okay, and I have different seeds. Alright, so that is mine, right? this is the one I found online, which is doing that slopey thing, but which mine's did originally. So this is just one octave, which is exactly the same implementation. And then this is Unity's Perlin noise. And the thing about Unity's Perlin noise, you can see that it does different amplitudes right away. But it keeps everything at this uniform distance. So what I'm thinking they're doing is when they're getting their when they're doing their lerping, they're not even stopping at the same point. They're stopping at different points in space. So they're changing that, like with the Perlin noise that we've done so far right here is like at every interval you're gonna stop at 0, I think, where basically there's always like a stop at 0 every one of these reds. You can see they kind of start off always at the same spot. So what I think Unity's Perlin noise is doing is that they're actually starting at different spots, and that's good too. So that's pretty good. But you know, for our purposes, I think this is fine. My only doubt is like right now we're not using the whole plane, this whole space. So we basically have to figure out, okay, for every octave, right? Like one octave will be 0 to 0.5. But you see, for this one, I divided by 2, so this could be 0 to 0.25. So 0.5 plus 0.25 is 0.75, and this is going to be like 0.825 or something like 0.875, and this would be 0.8 whatever. So then you want to map that across the whole space, like 0 to 1. So this is mapped maybe up to here and here, but maybe later you want to do it more. Just exploring the space right quick. And yeah. It's neat, but I think I like the modified version of the Perlin too. But this is a couple octaves and seems to be working fine. Okay. I'll stop. Why? Why do you hate that? I can't get past it. Once I like drag the offset here, it hates me. Something. It's something somewhere. But it's not giving me an error. Should I, yeah, I'll run the debugger. Maybe this will tell me what's going on. Yeah, no problem. I'm probably wrapping up soon, but yeah, just debugging. Oh, here we go. Oh no, it's me. What's going on? Okay. I've seen this. I think I know what to do here. Basically, the int part is just too big. Okay. Well, you see, it didn't tell me that. Okay. No problem, no problem. So if the int part gets that big, we should just modulus this at 256. And maybe the same thing here. And I'm sure in all my color calculation stuff, I'm doing kind of the same thing. Let's just modulus that to 256. And that way, it wraps. Let's see if that works. That's looking pretty good. How much mouse pad do I have on my desk? We'll find out next time on ET Stream. Okay. We can head back and see the same stuff. Okay, yeah, so it looks like we got that working. But let's just compare something right quick. Oops. We'll just call this more octaves. So we have this more octaves thing, but without the octaves, this is what we're gonna get. Get this. If I compare it to the online version, it's basically the same. But the online version one gives you like this predefined random list of integers. Like mine's, at least the addition I added, every time you change the seed, it changes all the numbers in the list. So you can kind of, change the seed and get different patterns. But, if I go to 5 and then go back to 0, you should get the same like pattern that you saw originally. Okay. Oh god. That was the 2D noise. We'll talk about that another day. But here's unities. You see, here's I guess the line, but it doesn't always seem, or maybe it does. But sometimes it doesn't, right? But maybe this is the line, and this is the line. So maybe it is always using this line. I guess I might do it. Just see what the spacing is this way. Print screen, paste screen, go here. Alright, so like, I'm assuming this is the line. Oops. How do I move that transform? View, transform. Why? Why is this so hard? How do I transform the transform? Alright, or you know what? I'm just going to make a line. Can I make a line? Or a circle? Or a box? Oh my god, why am I suffering so bad on this? Alright, I'm going to make a new layer. Sure. Make a line. Alright, so that's our line. Is there a point every time? See, like, I feel like that's a pattern. No! How do I lock that layer? Lock it. Oh, is that the lock? Good. That didn't lock it at all. Is that the lock? Alright, look, I just want to mess with this layer. Oh my god, this is going to be harder than I thought. Alright, I'm just going to hold down. I'm going to keep it held down. Alright, so this is kind of one increment, maybe. This is kind of one increment, maybe. This is kind of one increment, maybe. There's a chance that it's always hitting this 0 point right here. I'm starting to feel better about this. There's two, nothing happened. what's interesting is it seems to be using different equations. Maybe like this has that little ramp, and like this is definitely just like straight up that the lerping stuff we've been dealing with, right? And maybe this is also doing that straight up lerping stuff that we've been doing. And this is of course flat. And like this little artifact right here is very interesting to me. But everything else seems to be, I think this also has that artifact somewhere along it. Anyway, that's Unity's Perlin noise. I wonder if I could just do a quick, this is 660, 653. The whole thing is, it's a little lower than half, I think. It's 1212. Yeah. So it's not, it's a little bit higher than half. Okay. Anyway, so that's the Unity's Perlin noise. Okay. That was a good deep dive into Perlin noise. We'll have to do 2D in a bit, and then what we'll do next time is yeah, do the 2D Perlin noise, and then finally put it into the software that I'm actually working in. But I really needed to get a good understanding here and implement it. So in that case, let's go ahead and just, I know we didn't really do much in code except one class, so there should just be one class to commit. Oh god, alright. Yeah, so just this class. Add my understanding to Perlin noise and octaves. We'll probably try to make a random amplitude version like Unity's. And with that, let's just commit and push this. Okay, if you're here, thanks for joining me. I'll do the stream a little later today, where we will make a modified version of this noise, make it 2D, and I think that's what will be done for tonight. And then Monday, we'll go ahead and put that function into our tile editor. All right, bye guys.